Greetings again, Year 9, and welcome to another exciting lesson on sketching parabolas. So today we're going to sketch parabolas using intercept form, which is a totally different way to sketch them. There's many ways you can sketch parabolas. This is a very fast way if it's written in a particular way. So when we're graphing a parabola using intercept form, we've got to follow these rules. First thing that we have to do is factorize the quadratic. Remember, you're going to have to get equals 0 and factorize and a whole lot of things. Use the null factor law to find the x-intercepts. Now, the x value of the turning point is always halfway between the two x-intercepts. Once we know that, we can find the y value by doing some substitution. We'll do an example of all this so it makes sense in a moment. Find the y-intercept by letting x equal 0, and you can follow those steps. So let's try it for the first one. For example 1, it says for part A to find the x-intercepts. Now how do you find x-intercepts? Well, you find x-intercepts by letting y equal 0. So that's the process. You always let y equal 0 when you want to find where the graph touches the x-axis. So I'm going to rewrite the question. Remember, there's the question there. But everywhere I see a y, put a 0 in its place, and there's my question. That's just a null factor law question. If I want to solve that, I get x equals 0 and x equals minus 2. So they're my two x-intercepts. Let's find the y-intercept. How do you find y-intercepts? Well, to find the y-intercept, you let x equal 0. So we go to the original question, and everywhere we see x, we let it equal 0. Now, you could do this in your head or on the calculator. It's faster to do it in your head because if you look inside the bracket, 0 plus 2 is 2. But out the front, 0 times the bracket. 0 times anything is 0. So you just get y equals 0 for the y-intercept. Let's try example number 2. Find the x-intercepts. Well, how do you find an x-intercept? You find an x-intercept by letting y equal 0. So rewrite the question, but wherever you see a y, put a 0 in its place. Or we're going to null factor law it. We don't worry about that 3 at the front because there's no x with it. So x equals minus 3 and x equals plus 2 if we use the null factor law. How do you find a y-intercept? Well, to find the y-intercept, you let x equal 0. So we rewrite the question, but wherever we see x, we put a 0 in its place. Now, you could do this on your calculator, but I do this in my head normally. It's 3 because of the 3 at the front, times, what's the first bracket become? 3, because 0 plus 3 is 3. What's the second bracket become? Minus 2. So it's actually 3 times minus 2. 3 times 3 is 9. 9 times minus 2 is minus 18. So that's what we get. 3 times minus 2, which is minus 18. And there is the y-intercept. Let's try example 3. It says, consider y equals x squared minus 4x. So step 1, let's factorize it. Now how do you factorize? Well, you look for a common factor. Let's actually look for our common factor. We've got x squared minus 4x. Well, this is not a difference of 2 squares. It would be if it said x squared minus 4. It's a take out a common factor question, and the common factor is x. So I'm going to take out the common factor. If I take out x, I'm left with x, and take out x, I'm left with minus 4. So that is my factorized quadratic. Well, let's find the y-intercept. How do you find a y-intercept? Well, you let x equal 0. We discussed that earlier. So I'm going to rewrite the question, letting x equal 0. Now, notice, I could do that here, I could let x equal 0 in the question, or in the factorized version. It doesn't matter. If I let x equal 0 in either version, I always get 0 for this question. Next thing was to find the x-intercepts. How do you find an x-intercept? You let y equal 0. So we rewrite the question, letting y equal 0. And again, you can write the original question, or you could go straight to the factorized version, which would be faster, because if I write it like this, I have to factorize the quadratic. Now I can null factor law it. X is going to equal 0 because of the x out the front, and x is going to equal plus 4. So 0 and plus 4. What's the axis of symmetry? Well, the axis of symmetry will always be halfway between the x-intercepts. And if it's halfway between the x-intercepts, how do you find halfway between some numbers? You add them up and divide by 2. So my x-intercepts are 0 and 4. So 0 plus 4 over 2 is 4 over 2, which is 2. The axis of symmetry is the line x equals 2. Let's find the turning point. Well, I know the turning point always passes through the axis of symmetry. So the turning point is the point 2, something. I know it's 2 because the axis of symmetry is 2. The axis of symmetry is always the x value of the turning point. So we know it occurs when x equals 2. So when x equals 2, we substitute x equals 2 back in the original question, or in the factorized quadratic. It doesn't matter, either one works. So when I see x, I put a 2 in its place. So you get 2 squared minus 4 times 2. 2 squared is 4, 4 times 2 is 8, 4 minus 8 is minus 4. So the turning point happens at 2, minus 4. So I now know where the turning point is. Now we just have to do a sketch. Well, I need to put the turning point and the intercepts on. So the turning point is at 2 minus 4. I just go across 2 and down 4 and put a dot. I know this is a parabola that opens upwards because it's a plus in front of the x squared. So I also know it goes through x equals 0 and x equals 4. I put a dot at x equals 4 and 0. It goes through at y equals 0. Put a dot there. It's the same as the x equals 0 dot. And put my parabola in. Now you'll notice I put the 4 there. You probably should put a 0, but 0 is the only one you can get away with sort of sometimes not putting, but you should have put a 0 there. Let's go to example number 4. Okay, so we've got to consider y equals x squared plus 2x take 15, and the first thing we need to do is factorize it. Well, factorizing this, it's a monic quadratic trinomial. I need two numbers at times to give minus 15 that add to give 2. And the two numbers at times to give minus 15 and add to give minus 2. So they times to give minus 15, they add to give 2, sorry, I think I said minus 2. What are numbers at times to give minus 15 and add to give 2? They would be 5 and minus 3. And that's why I have a plus 5 and a minus 3 there. So that's how we factorize that. Find the y-intercept. You find the y-intercept by letting x equal 0. You can do that in the original question or the factorized version. So if I went for the factorized version, I let x equal 0, I'd get 0 plus 5 times 0 minus 3, which is a fancy way of saying 5 times minus 3, which is minus 15. It would have actually been quicker to go up here. Let x equals 0, that drops out. Let x equals 0, that drops out. The y-intercept is at minus 15. Find the x-intercepts. Well, you find x-intercepts by letting y equals 0. So we rewrite the factorized version where y equals 0, and then we null factor law it. Null factor lawing it, x will equal minus 5 and plus 3. Now we need to find the axis of symmetry. Well, the axis of symmetry is always halfway between the two x-intercepts. What's halfway between minus 5 and 3? When you want to do halfway between two numbers, you add them up and divide by 2. So you go minus 5 plus 3 over 2. And do that on your calculator or in your head. What's minus 5 plus 3? That's minus 2, and minus 2 over 2 gives minus 1. So the axis of symmetry is at x equals minus 1. Where's the turning point? Well, we know the x value of the turning point is at minus 1 because we found it here. So we plug minus 1 back into the original question or the factorized quadratic. So if I plug it back into the original question, you get minus 1 squared plus 2 times minus 1 minus 15. Notice I put the minus 1 in brackets. If it's in brackets, your calculator will give you the right answer. If you forget the brackets, the calculator will give you the wrong answer. Negative 1 squared gives 1. 2 times negative 1 gives minus 2. So 1 minus 2 is minus 1. Take away 15 gives minus 16. So the turning point is at negative 1, comma, minus 16. There it is, negative 1, minus 16. The x number first, the y number second. Let's do a sketch. Well, let's go to where we think minus 1, minus 16 is roughly. You go left 1 and down 16, just put a dot and label it, write it, minus 1, minus 16. We know this parabola opens upwards because it's a plus x squared. We know it goes through the y-axis at minus 15 and the x-axis at minus 5 and 3. So there's my x values of minus 5 and 3. There's my y value of minus 15, and the parabola goes through those points, and there is my sketch. And you'll notice that I labelled all of those points on the parabola. That's a must, because that's called showing the key features. Key features means show the turning point and the x and y intercepts. Well, time for you to have a bit of fun. Enjoy.